Let's try this third problem. So here we have two experiments using sodium and chlorine, and in the first experiment 4.36 grams of sodium are reacted with 32.24 grams of chlorine. So using up all the sodium, 11.08 grams of sodium chloride was produced in the first experiment. The same experiment was conducted but with different beginning masses. Here 4.20 grams of chlorine that reacts with 20.0 grams of sodium. So here in this time is all the chlorine was used, and the produced or the products is composed of 6.92 grams of sodium chloride. So show that these results are consistent with the law of constant composition. So here we can give just a scheme. Here we have the first experiment. So we have chlorine, and here we have chlorine. Chlorine is like this, Cl2. We have a mass of, in the first, 4.36 grams of sodium that reacts with 32.24 grams of chlorine. So here we have 32.44 grams that reacts with sodium of the symbol Na. The mass is 4.36 grams. So the obtained result is sodium chlorine, which is NaCl, that is, with a mass of 11.08 grams. So here, from this result, we can see that for every 11.08 gram of sodium chloride or product, we have 4.36 gram of sodium. Why? Because here it is said that all the sodium was used, because it was the smallest mass. So the smallest mass will be totally consumed. So here we can obtain the percent of sodium in the sodium chloride, and we have a result of, and by doing this calculation we got 39.4%. So if this is consistent with the law of constant composition, we must find the same percent of sodium in the second experiment. So here is the second experiment. In the second experiment we have used chlorine. We have used a mass of 4.20 gram and sodium 20.00 gram. So here the obtained sodium chloride has a mass of 6.92 grams. 6.92 grams. So here, how much is the percent of the sodium? So here, it was different. Why? Because using up all the chlorine, here all chlorine mass was consumed. So here we must get how much is sodium in this sodium chloride. How? We just make a subtraction. So we have the whole mass of chloride is 6. So here the mass of in gram of sodium is equal to the total mass of the product gram minus the mass that was totally consumed. Here we have 4.20 grams of chlorine. The result is 0.72 gram of sodium. Here we used three significant figures. So here, from this equation, we can see that for every 6.92 grams of sodium chloride, the product, we have 2.72 grams of sodium, and we'll calculate the percent of sodium in this second product, and here we must find the same value, okay, because it should be consistent with the law of constant composition. So here, by making the calculation, we get 39.4%. So here we can observe that both are the same. So we get the same result. So here, if we respect the significant figures, it was rather 39.3%. But it's not important. It is a very, very small differences due to the significant figures. So we have 39.4% of sodium in each samples. So we can ascertain that the definite proportions is respected. In the fourth numerical problem, we have a sample of methane that contains only carbon and hydrogen. So carbon and hydrogen, there are their samples. So it is given that with 3 grams of carbon for every 1 gram of hydrogen. So for every 3 grams of carbon we have 1 gram of hydrogen. How much hydrogen should be present in a different 50 gram of the same sample, or the same sample of the same methane? So here we have an important information that is for. So we have here methane. Here is the formula of methane. So for every 1 gram of hydrogen, here we have 3 grams of carbon. So we can assume that the smallest whole number combination of this element is 4.00 gram of methane. So it is assumed to, this value is assumed to be the smallest whole number combination of these two elements. So here, by a simple relation from dimensional analysis, we can get the mass of hydrogen in gram by dimensional analysis. So here we can give for 1 gram of hydrogen for every 4.00 gram of methane times the given mass of the same methane. Here we have 50.0 gram of methane. So here we can see that we can simplify methane, grams, and at the end we'll get the unit of gram of hydrogen, which gives, so here we have, here it is 4.0, not 4 here. So 1 over 4 times 50, which gives 12.5 gram of hydrogen. So in this sample, for the same methane, we have 12.5 gram of hydrogen. And the mass of carbon, we can deduce it from the subtraction of 50 minus 12.5, which gives about 37.5 grams of carbon.